This is a solution video for Chemistry Paper 1 Set 3. You can download the soft copy through the link from the description below or from the first comment below. And you also can skip to the end of the video for the answer straight away. Bromide ions and hydrogen ions react accordingly to the equation. So some operators are shown to measure the rate of reaction. So you have gas strange balance and pH meter. Which operators are suitable to measure the rate of reaction? Okay, so let's look at the products. So first thing first, if you see, initially it has H+, so it's acidic. But in the end it becomes water, so it becomes neutral. So you can use a pH meter to figure out the rate of reaction. So the pH actually increases as the reaction proceeds. Next, you can't use a gas strange because there are no gas producing. And the balance, I don't think there's a change in mass, so this one is not. So only answer that makes sense is 3 only, so it's B. Moving on. Question 2. A mixture of propane, butane, and hydrogen sulfide and CO2 at minus 30 degrees is allowed to cool gradually to 200 degrees Celsius. So it's from minus 30 degrees Celsius, it decrease to minus 200 degrees Celsius. So it's cooling. Okay, so you have the melting and boiling point. So which compound will solidify first? Okay, so it will go from liquid to solid first. Okay, so liquid to solid, so you should be looking at your melting point. So whichever is nearest to minus 30 degrees will be better. Alright, so it should be this one. Let me see. Yeah, minus 30 is here, minus 30 is here, minus 30 is here, and minus 30 is here. Yes. Okay, solidify. So you want to reach a solid state in the end. So CO2 will be the best candidate. Okay, because it has minus 78, which is nearest to negative 30 degrees Celsius. So answer should be CO2. So answer will be B. Next one. Question 3. This one should be separation techniques. Okay, let me write down first. So you try to obtain ethanol from a dilute solution of ethanol in water, and just take note, the boiling point of ethanol is 78. So which graph shows the change in concentration? The change in concentration of the ethanol in the boiling flask. So it's in here. So because we know that ethanol will boil off first, because water is 100 degrees Celsius and ethanol is only 78. So this is 78 degrees Celsius, water is 100. Okay, so the concentration of ethanol should get lesser and lesser. So it should, let me see. Okay, so it should be C. Okay, the amount of ethanol should decrease with time. So answer should be C in this case. Okay, no trick questions. Question 4. This one should be under atomic structure. So which option shows the number of particles, okay, for sulfur ions? So just list down 16 proton. Because it's 2 minus, so it has taken 2 more electrons, so it's 18 electrons. And if you minus 34 minus 16 will be, it will be 18 neutrons. Okay, so let's look at answer will be, yep, B. Okay, so just a simple calculation of all the particles. Question 5. So you have two isotopes, okay, oxygen 16 and oxygen 18. So relative atomic mass of carbon is 12. Which are the possible values of MR of CO2? Okay, so take note. So this is CO2. So this oxygen, right, you have three combination. It can be oxygen 16 and oxygen 16, or it can be 16 oxygen and 18 oxygen. So it's like a different combinations, or 18 oxygen and 18 oxygen. Okay, so let's calculate a fast one. So this will give you 44, including the carbon, alright. This is 46. This is 48. Okay, so all are possible. So answer will be D in this case. Moving on, question 6. Nucleon number is 31. Form an ion of Z3 minus. Okay, Z3 minus. Nucleon number basically means mass number. Means the number of proton plus neutrons. Okay, so if it's Z3 minus, so let's look at the periodic table. If you look at a periodic table, a mass number, so you should use the number at the bottom. It looks like phosphorus, so Z is actually phosphorus. Okay, so it has group 15. Okay, so it's found in group 15, that's all. Okay, so it's not group 5, so be careful. So answer will be B. Moving on, question 7. So X is 283, so it's actually 3 plus. Y is 6, so it's 2 minus. So they react together to form a compound. Okay, so you can do your crossing. So if you cross, you get X 2, Y 3. Okay, so once a metal, X is a metal, and this will be a non-metal. Okay, so definitely it will be ionic, and X will lose 3 electron. Okay, 2 atoms each lose 3 electron. Yep. And then Y will each receive 2 electron. 3 atoms each receive 2 electron. Yep. Okay, so answer will be B. Moving on. Okay, brass is an alloy of copper and zinc. Okay, so take note, it's an alloy. So basically, it's like a mixture. So which statement is correct? Okay, brass can be represented by a chemical formula is wrong. Okay, mixture has no formula. Brass is formed by chemical reaction, so no, there's no chemical reaction at all. Okay, it's just a mixture, like a physical. Brass will react completely with dilute nitric acid. This not completely. Okay. Zinc will react with acid, correct. Okay, but copper will not. Okay, so overall it's still a wrong statement. So this is under a reactive series for option C. Option D, the zinc in brass will react completely with dilute nitric acid. Yes, this is good. Okay, so answer will be D. Question 9. Which statement about the relative AR and MR are correct? Okay, so this is your atomic mass. This is your molecular mass. So the mass of different isotope does not affect the relative atomic mass. The mass, it does affect. Okay, so it's percentage. Okay, weighted percentage. So does not affect. So it is wrong. Okay, it will affect. Okay, number 2. Only covalent compound have a relative molecular mass. That is true. Okay, for covalent you'll get molecular. If it's ionic, it will be relative formula mass. Okay, and if it's an element, it will be relative atomic mass. Okay, so yeah, different names. So for statement 2 is true. Statement 3, relative atomic mass are compared to 1/12 of the mass of one carbon 12 atom. Okay, that is true as well. So answer will be C, 2 and 3. So this is under mole, this whole question. Question 10. Hydrogen react with bromine to form hydrogen bromide. So the formula is HBr. So which diagram shows a representation that is not yet completed? So you should still have some remaining H2 and bromine. So molecules. So should be this one. So this can be H2, then this is your Br2, then this HBr. Alright, so answer would be B. Question 11. Investigation for the products of the chloride in period 3 elements. Okay, show that the boiling point of sodium chloride and silicon tetrachloride is 1465 and compared to 57. So this is actually 57, which is quite low, and this is quite high, 1465 degrees Celsius. So the difference will be what? So obviously this one, ionic sodium chloride will be ionic structure, okay, whereas silicon tetrachloride, in this case, since it's so low, most likely it will be a simple molecular. Alright, so the difference in the boiling point are, let's see, covalent bonds are weaker is not true. In fact, covalent bonds are stronger than ionic bonds. Okay, so this statement is wrong. Metallic characteristics, character decreases across the period. It's true, but it doesn't explain the situation. So I just put a question mark first. Silicon form weaker bonds with chloride. Have weak intermediates. I think the best answer should be this. Yeah, C just doesn't make sense at all. Okay, so answer would be D. That's the best answer. Alright. Question 12. So you have two comments. So hydrogen chloride has strong covalent bonds in its simple molecular structure, and then hydrogen chloride are soluble in water. Actually, both are true. So which statement is correct? Let me see. Both are correct. Both are correct, but comment 1 does not explain comment 2. Okay, so both are true, but they doesn't explain each other. So answer should be B. Alright. Thanks. Bismuth is the same group as nitrogen. So nitrogen is group 15. So group 15. So bismuth formula should be 3 minus as well. Alright. So lithium is plus, bismuth is 3 minus. So if you cross, it will become Li3Bi. Li3Bi. Okay, so answer is will be D. Moving on. Question 14. Which compound contains the greatest number of atoms? Okay, in 1 gram. So take note is atoms. So this is the keyword. So we will do the formula mole equals to mass over 8R or MR. MR in this case. Okay. Then after that you still have to times your Avogadro's constant, because to get the number of mole of atoms. Okay. So this one I just leave it here first. Okay, I'll find the mole first. So CO2, so will be 1 over 44, the MR. Okay, but take note, this one, when you find this one, right, is just for the molecules. Okay, but in 1 molecule of CO2, there actually are 3 atoms, 1 carbon and 2 oxygen, so you have to times 3. Then times your Avogadro's constant, if you really want a full working, is 6.02 times 10 to the power of 23. Nitrogen monoxide will be 1 over 14 plus 16 is 30 times 2. Why is it times 2? 1 nitrogen, 1 oxygen. Then you times this one, the same thing. Then ozone, which is 1 over 3 times 16 is 48 times 3. Okay, because there are 3 oxygen atoms. Then times Avogadro's constant. And then sulfur trioxide will be 1 over 32 plus 48. 32 plus 48 will get 80. Then times how many atoms? 1 sulfur and 3 oxygen, so it's 4 atoms. Then times Avogadro's constant. So if you want, you can just ignore the Avogadro's constant because it's all the same. So it doesn't really matter. So you just need to calculate this. Okay, let me try the first one. So this I will get about 0.0682 mole. And then this 2 divided by 15. 0.0667 mole. 0.0625 mole. 4 divided by 0.05 mole. Alright, so since you want the greatest, answer will be A. Okay, so take note, when you use this formula, mole equals the mass over mR, you're just looking at the molecules, but they want atoms. So this is the part where some students might make the mistake. So you have to times one molecule, how many atoms are there? For CO2 will be 3, and NO will be 2, and so on and so forth. Okay. Question 5, mole concept still. Okay, so it's mole. So 200 cm cube of ammonia. So this is 200 cm cube. Oxygen is 100 cm cube. So what volume of gas will be collected at the end of the experiment when it's cool to room temperature? So when cool to room temperature, one thing to take note is what? H2O will be in a liquid state. So you do not involve H2O. Okay, so basically you're looking for this, okay, and see if any excess reactants. Okay, so this one is actually a mole and it's limiting. Reactant. Alright, so let's do the mole ratio. NH3, O2, 4:3. So if ammonia, I have 200 cm cube. This one I need oxygen, I need 150 cm cube. Okay, so both are gases, so you can just do your volume ratio. You don't have to do mole ratio. Okay, only for gases compared to gases. So I need 150, but the amount of oxygen I had is only 100, so they are not enough. Okay, so means my oxygen will be the limiting reactant. Okay, so now coming back, so now if oxygen gas is 3:4, this is 100. Okay, so 4 unit will be 133.3 cm cube. Okay, so the amount of excess NH3 will be 200 minus 133.3. Okay, so there will be some remaining ammonia, 66.7 cm cube. Okay, and don't forget, so now you must calculate N2 as well. Okay, so N2, so it's oxygen gas to N2 ratio 3:2. If 3 unit is 100 cm cube, 2 unit will be 66.7. Okay, so now you just need to add up this one and this one. Okay, because these two are the gas that are left behind. Okay, so 66.7 plus 66.7, so you get 133.3 cm cube. So the best answer, yes, will be C. Okay, so this is a slightly longer working. Okay, let's continue with question 16. So 30 cm cube of 0.1 mole per dm cube of sodium hydroxide react with 25 cm cube of sulfuric acid. So what's the concentration of the acid? So first you have to write your balance equation. So let's write this one. NaOH. Okay, so important, your equation has to be balanced because the ratio is 2:1. Okay, so let me write down the value. And acid is just 25 cm3. So this is your usual three-step template. So you have to find the mole of your starting point, then you link it to the ending point. Okay, so first we will do a mole of NaOH equals to CV. Concentration is 0.1, volume 30 divided by 1000. Okay, so you get 0.003 mole. Then you can do your step 2, which is your mole ratio of sodium hydroxide to sulfuric acid, 2:1. So if this is 0.003, here will be 0.0015. Okay, then the last step is a mole of H2SO4 equals to CV. So the mole we already have is 0.0015. Concentration is the one we are looking for. Volume is 25 over 1000. So concentration will be, okay, so you'll get 0.06. So answer will be C. Next, question 17. So this one will be under mole as well. So what's the percentage purity when it's 600 gram of tin ore? So this is 600 gram, but this contains impurity. So when you write 600, you have to circle it. So just to take note that it contains impurity. It's not 100% is tin oxide. And then you start from 82 gram of tin. So tin is this, so it's 82 grams. All right. So same thing as three-step template. So from here, you have to go to here. Okay. So coming back, first step is to find the mole of tin. Will be mass over AR. So it's 82 over AR. They give it to you 119. That's the mole. Next, your mole ratio, SN dot SnO2. So the ratio is 1:1. So if this I have 82 over 119, this will be 82 over 119 as well. And lastly, I want to find the mass. Okay, so I have the mole of SnO2 equals to mass over mR. 82 over 119 equals to mass over 151. So your mass will be 82 over 119 times 151. This will be in terms of gram, okay? But they want percentage purity, so therefore percentage purity will be this mass divided by the original, which is 600 grams, times 100%. Okay, so if you see carefully, the answer should be A. Okay. Question 18. Hydrocarbon. Uh, 85.7 is carbon, 14.3 is hydrogen. So the molar mass is 56 grams per mole. So what's the molecular formula? Okay, so this is under empirical formula. So you have to come up with your table. So let's just squeeze in here element mass percentage, okay, or mass, then it's AR, then it's mole, then it's ratio. So in this case we are using carbon and hydrogen. The percentage by mass will be 85.7, this will be 14.3, carbon is 12, hydrogen is 1, so you just divide 85.7 divided by 12. 3SF is good enough. 7.14 is 14.3, so you divide by the smallest number. 14.3. Okay, so it's pretty close to 2. Then there's 1. Okay, so therefore your empirical formula will be CH2. Okay, then now from empirical formula to molecular formula, you need the common ratio. So there's this formula, N equals to MR of molecular formula over MR of empirical formula. This is formula. Okay, so MR of molecular formula, which is given to you, 56, MR of empirical formula, which is CH2, which is just 12 plus 2. Okay, so you get 4. So the common factor is 4. So this one you have to times 4 to everything, so you get C4H8. That's the molecular formula. Okay, so answer will be D. That is how you do it. Alright, moving on. Question 19. You have a blue litmus paper, so with concentrated NaCl, okay, and then you have your current passing through. Which of the following shows the correct observation? Okay, after some time. So first thing first, concentrated NaCl. So this sounds like a electrolysis question. So first you have to write down the ions. So let me push up a little bit. So this you have Na plus, Cl minus, H plus, and OH minus. Okay, so since this is positive, so the negative ions will be attracted towards here, and OH minus, and then this one will be H plus and Na plus. All right. So electrolysis. So which one will be discharge? Okay, so which one is lower in the regular series? So hydrogen will be coming out. Okay, it's lower. Okay, and then at the positive electrode, because it is what, concentrated, okay, because it's concentrated, chloride ions will be discharged. Okay, so take note. So let's look at the option. So negative electrode and the positive electrode, chlorine will be coming out, so it will, negative electrode, because H plus at the negative electrode, it will be discharged. Okay, so there's no more H plus, so it won't turn red, so the paper will still remain blue in color. And then at the right side, positive electrode, your chlorine ion will become chlorine gas. Okay, so it become chlorine gas. So how do you test for chlorine gas? So you turn your blue litmus paper red, then bleach it. Okay, so answer must be A. Okay, so this will produce hydrogen gas. Okay, next one, question 20. So this is your simple cell. Because you're using two different metals, okay, and there's no battery involved, so this is not an electrolytic cell. Okay, so it's a simple cell. Okay. So important using copper and metal T. So which of the following statement is correct? So let's look at this one first. So from here you can tell the electron will always come out from the more reactive electrode. So in this case, copper will be more reactive. So in other words, it means electrode made of metal T. This T must be less reactive than copper. Most likely will be, for example, just for example, is like silver. Alright. So what happened at copper electrode? Copper will oxidize to become copper 2 plus. Whereas what happened at electrode metal T, right? You will look at the cation of the electrolyte, which is your H plus. Okay, so H plus will plus 2 electron to become hydrogen gas. Alright, so here you will see a lot of bubbles. Whereas for copper electrode, it will decrease in size. Okay, so you will get smaller and smaller, and the solution will become blue in the process as well. Alright, so coming back, so copper is less reactive. No, it should be more reactive. Eversion will be observed at T. Actually, yes, because you produce hydrogen gas, like what we explained just now. Oxidation occurs at metal T. Oxidation H plus to 0. No, it's actually reduction, so it's wrong. The mass of copper electrode will increase in size. No, it will decrease in size. Okay, so answer will be B. Okay, so if you know exactly what's going on at both electrodes, you will get the answer straight away. Okay. 21. Let's start. The graph shows the mass of precipitate formed when lead 2 nitrate and nitric acid is added. Okay, lead 2 nitrate and nitric acid. Okay, so you're trying to calculate the mass, trying to figure out the mass of precipitate. So when you add lead 2 nitrate, the mass of precipitate increases. Means actually there's a PPT form. So this PPT can be what? Can be lead sulfate, or can be lead chloride, can be lead carbonate also, or even lead hydroxide. Okay, but when you add acid, it actually remains what? Constant. So means this PPT does not react with the acid, so it can't be carbonate and it can't be hydroxide. Okay, so it's either sulfate or chloride. Okay, because these two ions will not react with the acid. Okay, look at this one. So this is very similar. Okay, so it can be lead sulfate, lead carbonate, lead chloride, or lead hydroxide. But the fact that when you add acid, it actually decreases in mass means what? Means this PPT will actually react with your acid. So the one that will react with acid is either this or this. So it's either a carbonate or hydroxide. Okay, so if we narrow down, so sulfate, it can be sulfate or chloride. This one, it can be either carbonate or hydroxide. Okay, so by elimination it will be A. Okay, so this is a bit more confusing, so be careful. Question 22. This looks like a QA question. So you have the green solution W. Okay, so when you add sodium hydroxide, this to test for your cations. So you have a green PPT. So this green PPT most likely will be iron hydroxide, iron 2 hydroxide. All right, and add sulfuric acid. So you have green solution. This green solution will be iron sulfate. Alright, so aluminum foil and heat it is to test for nitrate ions. So you have ammonia gas produced. So means this solution X contains nitrates. Okay, and since here there's no nitrates, means the nitrate actually came from here. And because the there's iron 2, so here should be iron 2 as well. It's green. Okay, so this will be iron 2 nitrate. Iron 2 nitrate. And this one, if you exchange partner, this will be sodium. Okay, so it will be sodium nitrate. So you got everything: sodium nitrate, and this iron 2 sulfate, iron 2 hydroxide, and iron 2 nitrate. Yes. Okay, so answer will be C. Okay, so just look at the reagent that they add and the color of the solution or the precipitate. That will give you the clue. Question 23. A student wished to prepare a sample of zinc chloride. So he carried out the experiment, the steps. So let's see. Zinc chloride is soluble, okay, and it's not a sparse salt, so it's method 1. So it's acid with excess insoluble solid. This is under salts, preparation of salts. Alright, so this is the first method. So let's see. Okay, so this should be the first step. Add excess. This should be the first. Put acid in the beaker first, then add excess zinc. Then you filter to remove the excess zinc. Then you heat it. Then you cool it to get your crystals. Alright, so number 1 is the last step. 4, 2, 5. 4, 2, 5. Yeah. So answer should be C. Okay, under salts. Moving on, question 24. So these are metal carbonates under reactive series. The company of 3 metals. So this gas evolved. YPPT. Solid does not change color. Solid change color from green to black. So this is a straightaway giveaway. Is copper carbonate to copper oxide. Copper carbonate is green, alright, and then copper oxide is black. So this metal definitely is copper. So no observable change means it's very reactive. Okay, so this metal carbonate will not undergo any changes with heating. So it can be either, from your textbook, it can either be potassium carbonate or sodium carbonate. And X will be somewhere in the middle. So okay, let's come back. X is more reactive than Z. No, it's less reactive. Z is the most reactive. So Y is a transition metal. Yes, copper is a transition metal. Metal Z can be extracted from its molten ore by electrolysis. Yes, that is true, because it's very reactive. So you can only extract through electrolysis. So answer is 2 and 3. So it's C. Moving on, 25. Okay, this is your 3 simple cell using copper, aluminium, and 2 unknown metal. So it's submerged into dilute sulfuric acid. From this result, deduce the order in the increasing ease of oxidation. Alright, so let's look at the first row. Copper and aluminium, right, you get 2.02 volt. But third row, copper and X only have 1.11. So this shows that aluminium will be higher than X, and then copper will be somewhere at the bottom. And then if you see carefully for the second row, copper and W, right, is 0.45. So it's even lower. So W must be lower than copper. So this is the most reactive. So increasing ease of oxidation. So you start from the least reactive metal. So you start from here, you go up. So answer will be C. Alright. Question 26. So this is your halogens, group 17. So X is a liquid, Y is a solid. So liquid, most likely this will be bromine. So this is solid, you can take it as is iodine or astatine. Either one is fine. So which of the following statement is correct? Atoms of Y means iodine has more electrons than atoms of X is true. A molecule of Y has more atoms than a molecule of X. No, both of them are diatomic, so it should be the same. Both have 2 atoms. Alright, so X can displace Y from a solution of Y minus. Yes, it's true, because bromine is more reactive than iodine. So it's 1 and 3, C. Next, 27. Metal X undergo reaction. So from here you have to work backwards. So let's look at this. X from here you can tell is 2 plus. It can react with hydrogen. So it means it's actually below hydrogen in the reactive series. So Okay, it's more reactive than X, metal X. So X can be like copper or somewhere lower in the reactive series. Okay, and then X react with acid. Okay, so X can react with acids, so it will be above lead. Okay, so let's do by elimination. So it can't be this one because it must be 2 plus. It can't be calcium because it must be slightly lower than hydrogen. So by elimination, it should be iron. Okay, somewhere near hydrogen or below lead, above lead. I mean, okay. So B is the best answer. This under metals. 28. Which of the following reaction when added to iron 2 chloride takes place in a redox reaction? Alright, so let's see. It will be this, because this is your famous oxidizing agent, so your iron 2 will be oxidized to iron 3 plus. Okay, so D. So your potassium manganate 7 will cause iron 2 chloride to undergo oxidation. Okay, let's look at this one, question 29. So you have a table of all the information. You have to rank them in the order of increasing order. Alright, so let's see. S has no reaction, so S is definitely the lowest. And then which one is the most reactive metal? Will be R, because R displays the rest. Okay, and then Q is the second one. P can only displace one, so P is the third. So in the increasing order, so you start from the bottom. So S, P, Q, R, C. Moving on. This is X, energy changes. So what's the enthalpy change of the reaction? Okay, so first you must calculate energy absorbed. So this one, the drawing is already drawn here, and then hydrogen is a single bond. Okay, for this it will be alright. So energy absorbed. So you're going to break this one, and this one. Okay, CH bond is 413 times 2 plus CC triple bond. CC triple bond is 839 plus 2 of the hydrogen bonds, HH bond, so it's 2 times 432. Okay. So you get 2529. Now you calculate energy release when you form the product. So CH bond, from here you have 1, 2, 3, 4, 5, 6, 6 of it. So it's CH bond 413 times 6 plus the CC bond, there's only one, which is 3, 4, 7. So absorb is plus 413 times 6 plus. So this release 2825. Okay, so then enthalpy change is everything add up. It's a 5 plus negative 2825. So it's alright. So answer will be A. Question 31. Which one is endothermic? Endo means what? Take in energy. Okay. and then it become cold, the surrounding. So let's look at the possible options. Take in energy. This one is a steam, is give out, so this is exo. Burning definitely is exo, also combustion. Okay, neutralization is definitely exo. So this one, thermal decomposition, because you take in the heat. Okay, so answer will be C. 32. Conversion of P into Q is negative. Negative means is exo. Okay, then it was found that the reaction proceeded by the way of compound Q. So Q to R is positive. Then it's endo. Alright, so answer is exo. Exo, yeah, so it go lower. So Q must be lower. So this is out. And then when you reach to R, R must be higher than Q. So it's like Q must be lower, then R must be higher than Q definitely. So answer that makes sense is this one, yeah, C. Right? This is wrong because there's a missing hump. So you're looking for the activation energy. So this is out. Okay, and this one doesn't make sense. So yeah, answer is C. Okay, so take note. Question 33. X and Y represent the result of two experiments using catalytic decomposition of hydrogen peroxide. Okay, so H2O2 to give you 2 water plus oxygen gas. Which set of value of hydrogen peroxide will give the result? So X, you can tell that Y is faster because the gradient is steeper, but X will give you more products. Okay, but it's slower. It's faster, but it has less products. So let's see. If you want to see who is faster, you have to look at concentration. So experiment Y is faster, so the concentration must be higher. This is 1, this is 2, so this is out. Okay, 2, this is possible. This is out. This is possible. Okay, so it must be big, a larger concentration, a higher concentration. Next is the products. So Y must have less products. So to find the products, right, the mole of products is mole equals CV. Okay, concentration times volume. So this times this, you get 100. Okay, you can ignore the cm cube. Okay, you just want the ratio of it. So this is 100, and then these times together will give you 100 as well. This one times together you get 200. Okay, so you must have more products for X. So this is the one. So answer would be D. Okay, A and C definitely they are out. Okay, so under rate of reaction this question. Question 34 starts to go to your organic chem. Fractional distillation of crude oil, so obtained at the top and bottom layer. So which property do the fractions obtained at the top differ from those at the bottom? Okay, those at the top is more viscous is wrong, is less viscous, burn more easily, that is true. Lower boiling point, that is true. So 2 and 3 answer will be D. Next, 35. Complete combustion of 20 cm3 of gaseous alkane, so take note it's an alkane. Give you 100 cm3, require 100 cm3 of oxygen. So if you write the formula will be CXHY plus O2. Okay, since this 20 cm3 and this 100 cm3, so you can reduce the ratio to 1:5 because both are gases, so you can do your volume ratio. Okay, so there's no need to do your mole ratio. 1:5. So means if this one, I can add in the 5. Okay, then coming back, so you just do by elimination. So you have to react with 5 oxygen. So let's do try and error. So let's say I do B. Okay, So let's say if I do C2H4 plus O2, okay, so I get CO2 plus H2O. I'm sorry, it's an alkane, so it's, let's say, C2H6. So you try to balance two carbons, so it's 2 here, and then hydrogen, there's 3, so there's 4, 7, so it's 7/2. Okay, so it's not correct because you're looking for 5, not 7/2. Okay, so let's try again. Let's try one more at the bottom. Let's try butane, C4H10 plus O2. You get CO2 plus H2O. So for carbon 5, 9/2. Yep, okay, so it is wrong as well. It's because you are looking for exactly 5. Let's squeeze in somewhere. Let's just erase this one. Let's try propane, C3H8 plus O2. So 3 carbon and then 4, so you get 6, 10, so it's 5. Yeah, that's the one. Okay, so answer will be propane, 3 carbon. So answer is D. So this one you just have to do try and error until you get the correct ratio, which is 1:5. Okay. How many isomers are there for butyl 2-nol? Okay, so it's connected to the second carbon. This is the second carbon. This is the first carbon, second carbon, third carbon, fourth carbon. So important thing is where is the OH located? Okay, so let's try. So you can connect to the first carbon, that's 1 isomers. Second isomers, if you connect to the third carbon, right, this and the original one is actually the same because you can just flip it around. Okay, left become right, right become left. So this one is not considered isomers. Okay, and what if you put your OH here? So number 1 and number 2, they are actually the same because you can just flip the chain. Then 1 and 2 are actually the same thing. Okay, so this is not a mono isomers. So the only one that makes sense is you have to try to change to a branch chain. Okay, so something like that. So let's say I connect to the this. Okay, okay, so now I connect to this. Okay, so number 3 and number 2 are totally different. Okay, I think that's the combination. So I think there's only 3 in this case. So answer is C. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogen. Okay, and 1 OH. Question 37. An ester, okay, so you have this formula esters undergo hydrolysis. So basically it's the reverse of esterification. So you go back to get your alcohol and your acid H. Okay, so alcohol G can be oxidized to acid H, so by OA. So this shows that what, G and H have what, same carbon atoms. Okay, so since it's 6, so both are 3 carbon. Okay, so it's propanol and propanoic acid. So what's the formula? So formula is this is this is 4 is wrong. I think this is the correct one. So if you chop up your ester linkage, so it has 3 carbon here, and then this has 3 carbon. 2 plus 1 is 3. So answer is B. Okay. Next one, 38. So this is the this is a structure. So this is your carboxylate group, and then this is your CC double bond. Okay. So this is your carboxylic acid. That's a missing one. Okay. So it can react with bromine, yes, because of the alkene CC double bond. It can react with alcohol to form esters, yes, because of the carboxylic acid. It can react with sodium metal, yes, because it's acid still. So answer is D. 39. So which row correctly describe the monomer of Q and how is it formed? Okay, so one look at it, you can tell this is your amide linkage. Okay. So functional groups present in a monomer. So to form amide linkage, you need a dicarboxylic acid and a diimine. Okay, meaning you need a NH2 and then you need a COOH. Okay, and this one in the process they will remove water, so it's a condensation polymerization. So answer is D. Question 40. This is under air. Which shows the correct effects. Okay, so let's see. CO2 is a greenhouse gas, is not really poisonous to human, so it's wrong. CO does not deplete ozone, it should be CFC. Okay, and then NO forms acid rain, that is true. CFC layers form photochemical smog, I don't think so. Okay, so answer will be D. Okay, that's all. Like, share, subscribe.